In this video, we're going to find the average rate of change of f of x is equal to x squared plus 2x plus 3 from x equals -5 to x equals 0. Now you can see the formula for average rate of change written in blue. It is f of x2 minus f of x1 divided by x2 minus x1. But notice what I have written out beside it. I have or, you could say it's the same thing as y2 minus y1 over x2 minus x1. And that is our formula for the slope. Remember, that is equal to m, our formula for slope. And the reason that I say that these are like the same thing is because really they are. The average rate of change formula is just kind of like a special version of your slope formula, where instead of using y values, you're using function notation. And really, for the purposes of this class, anytime you see a y, you can change that out for f of x anyway, as we're talking about functions from this point on. And so I just wanted to kind of, plant this idea in your mind. It's not another formula you have to memorize. Really, it's the same thing as the slope formula. You can just think of y2 as the f of x2 and y1 as the f of x1. So now let's go ahead and apply this formula, the slope formula, to our particular problem. So I'm going to go ahead and erase the slope formula over here on the right-hand side and just leave us with our average rate of change formula. That's what I meant to say. And so what we need to do is we need to figure out the f of x2 and the f of x1, and then we're going to plug those into the formula. Now you could do this all in one step if you wanted to, but I think it's easier to kind of make it into little modules of work you have to do. Just compartmentalize the labor so you're less likely to make a mistake. So let's go ahead and label our x2 and our x1. So I'm going to call x equals -5 our x1 and x equals 0 our x2, because it's the first and second x value. And so now that we've labeled it that way, we can figure out the f of x2 and the f of x1. So the f of x2 is the same thing as the f of 0. And the f of 0 is the same thing as putting 0 in the place of x in our original function. So that's going to give us 0 squared plus 2 times 0 plus 3. And of course, that's just going to give us 3. So the f of x2 is 3, so whenever we plug everything into our formula, we're going to put a 3 right there. So now let's do the same thing for the f of x1. Unfortunately, this is going to be a little bit more work because it's not a 0. So the f of x1 is going to be the same thing as the f of -5. And so we're going to this time put a -5 in the place of x everywhere we have an x. So that'll be parentheses -5 squared plus 2 times parentheses -5 plus 3. And then our -5 squared is going to give us positive 25. 2 times -5 is going to give us -10 plus 3, and that's going to give us 18. Because 25 minus 10 is 15, plus 3 is 18. And so that's going to give us our value for the f of x1 right there. So let's go ahead and plug those numbers into our overall formula. So f of x2, that's going to be 3, minus the f of x1, that's going to be 18, over x2, well, we know x2 is 0, minus x1, which we know to be -5. And so now we've done the work, we just want to simplify. So in the numerator, 3 minus 18 is going to give us -15, and in the denominator, 0 minus a -5 is the same thing as 0 plus 5. So we end up with -15 over 5, which gives us -3. And that's going to be our answer. So again, if you have a problem that deals with the average rate of change, I would break it into components and figure out the f of x2 and the f of x1 first, and then plug everything in the end. And I think it just makes the work a little bit easier, makes it to where you're less likely to make a mistake. And the other thing to keep in mind is this is not really another formula you have to memorize. Really, if you've memorized the slope formula, which you need to, you've already memorized the average rate of change formula. So keep that in mind and it'll help you.